Hello guys, welcome to the channel MyOneTeacher. In this video, we will continue our topic graph theory. So let's start. So in this video, we will cover a topic Eulerian graph. The topic is very important and interesting. So let us start. So what is Eulerian graph? If I join four vertices, suppose A, B, C and D, suppose it's a square. Okay, suppose this point is A, this one is B, this one is C and this one is D. And in this four edge, if I start from A, then by passing through all these vertices, if I end at vertex A again, so in this case, the graph is called Eulerian graph. It's also called Eulerian circuit. So let us learn more about this topic, Eulerian graph. So first of all, Eulerian circuit, the definition is given here. An Eulerian circuit is a circuit which traverses every edge exactly one. You can see in this one also, I travel all the edge exactly once. Okay. So, and it's a circuit and exactly once. Okay. But what is Eulerian trail? A Eulerian trail is a trail which traverses every edge exactly one, but does not start and end at the same vertex. That means the example I gave is an Eulerian circuit, not an trail. What will be the Eulerian trail? Here is one example of Eulerian trail. You can see here, it started at point A, then it moved from A to B, then B to C, C to again A, then E, then D, then ended at C. Now see one thing, first of all, it travel all the edge exactly once, and it started at A, you can see here also, and ended at C. So it's an Eulerian trail. Clear? Now first one, it's an Eulerian circuit. You can see it started at A, then it covered all the edge exactly once and ended at A again. You can check this path. So this is an Eulerian circuit where it will travel all the edge exactly once, and also it will start and end at same vertex. Clear? If there is any doubt in this two topic, you can ask me in the comment box. Now next, a graph can be Eulerian or a graph can be semi-Eulerian. Let us understand both. So, a connected graph will be Eulerian if no vertex of odd degree. That is, if there is no vertex of odd degree. For example, here you can see all the vertex. If A vertex, degree of A vertex is 2, 1, 2. Degree of B vertex is also 2. Degree of C vertex is also 2. For D, it's also 2. So for all four vertex, degree is 2. Important is degree is even. So it's an Eulerian. But if a connected graph is semi-Eulerian, and if there is exactly two vertices or two vertices of odd degree, then it is semi-Eulerian. Clear? For example, if we check this graph, if I check degree of all the vertex, then see what I will get. For vertex A, degree is 3, 1, 2 and 3. For vertex B, degree is 2. For vertex C, degree is 3. For D, it's 2. For E, it's 2. So what I get is, for vertex A and C, degree are odd. That means it's semi-Eulerian. Clear? So definition is very simple. If all the vertex had even degree, then it is an Eulerian. If there is exactly two vertex with degree odd, then it will be semi-Eulerian. In semi-Eulerian, for the other vertex, obviously it will be even. Okay, so next, let us solve this problem. Okay, what they ask? So that this graph is semi-Eulerian. Okay, so as we know, in semi-Eulerian, there will be exactly two vertex with odd degree. So let us check degree of A. For A, degree is 1. So we got, till now we got one vertex with degree odd. So I will mark those vertex with degree odd. Now for B, degree is 4 because 4 edges are connecting this vertex. So I am not marking this because it's even. For C, degree is 2 because 2 edges are connecting. So again I am not marking this vertex. For D, it's 3. So this is another vertex with odd degree. Now for E, it's 2. Okay, so it's also even. That means except A and D all have even degree. Only A and D had odd degree. That means it's an semi-Eulerian since degree of A and D are odd. Let us check answer of number A. Yeah, exactly vertices A and D have odd degree, so the graph is semi-Eulerian. Clear? So if there is any doubt till now, you can ask me in the comment box. Next, find an Eulerian trail, that is the path. So let's start with A. You can start with any vertex. So from A to B. From B you can go to C, C to D, then D to B, then B to E, then E to D. Okay. The thing is that whenever you will draw this path, remember it should pass every edge exactly once, because that is the definition of Eulerian. And its trail, so it can end anywhere. Okay, the starting and ending point will not be same. So in this you can see it started at A and ended at D. Maybe this path is written. Let me show you that. One such trail, so it can be, your answer can be different from me, so it can be anything, but yeah, the thing is that it should pass every edge exactly once. So you can see here one such trail is A to B, B to C, C to D, D to B, B to E, then E to D. Exactly what I have done. Okay, next is add an edge so that resulting graph is Eulerian. Okay, find an Eulerian circuit in this case. Okay, so let us add an edge. So how we will add an edge? So we will join that two vertex which had odd degree. Very simple. So that means A and D had odd degree. So simply we will join A and D. So if you join this two, then this will be Eulerian. So any semi-Eulerian can be make Eulerian by joining the vertex which had odd degree. So circuit is very easy. Now you can write the same trail, this one. Then you can add D to A. So it will end at same vertex. Yeah, you can check here. A to B, B to C, C to D, D to B, then E, then D, then ending at A. So it's starting at A, ending at A, and passing all the edge exactly once. So it's now Eulerian circuit. Clear? So this is the first part of this video. If there is any doubt in this first part, you can ask me in the comment box. Coming back to next topic, the Chinese postman problem. Very interesting type of sum. So suppose a postman has to leave from a depot, travel along a set of number of roads to deliver the mail, then return to the depot. How should he do this so he travels the minimum distance? What does it mean? Suppose a postman started at some point A. Suppose this will be that vertex or point where he started. Then he will deliver some mail in some point A, maybe some location C, then D, then E, then lastly will come back to the initial point. Now how should he select the edge so that distance cover will be minimum? So that we will solve using this concept, Chinese postman problem. So let us solve one sum. So what is the sum? Let me check. Solve the Chinese postman problem from this weight graph. Okay, so the graph is given. In this graph, the numbers, remember, these are the distance of the vertex, that is length of this edge, you can say. Okay, so we have to find the minimum one. Okay, now here how we will solve? You can take any vertex wherever you want to start. You can start at B or A, anywhere. So you have to cover all the edge exactly once. Okay, suppose it is Eulerian circuit. Then it's very simple. You have to cover all the edge exactly once and you can easily come back to the initial point. But if there are some vertex with odd degree, then you have to join some vertex, or not join, you have to cover some edge twice. Okay, so maybe in this one also we have to do that. So let me show you this one, how to solve. So if we start at A, let us count the degree of all the vertex. For A, degree is 3. Okay, so this is one vertex with odd degree. For B it's 2. Okay, for C it's 2. Okay, even. So for D it's 3. Okay, again a vertex with degree odd. For E it's even. That means these two vertex are vertex with odd degree. That means it's an semi-Eulerian. So in this case we have to cover AD twice. Okay, so you have to cover AD twice, but remember you have to select that edge or that path which will be minimum. For example, AD you can travel directly from here to here, or it can be traveled through E, that is A to E, E to D, or it can be covered from this path. But which one is the shortest? AD is the shortest. So let me erase the other one, this one and this one, because this is 2. Other one you can see, if you count 2 plus 1 is 3, and this will be even larger. So 2 is the minimum. So what will be the minimum distance? If we start at A, you can move from A to B, B to C, C to D, D to A, then from A to E, let me write here, A to E, then E to D, then again end at initial point where he had started, that is A. Now here if you check this path, he is traveling AD twice, A to B, B to C, C to D, D to A to E, then again at D, then from D to A. Clear? So what will be the distance? If you count all the length which you have to cover, that will be 11. Why 11? 2 plus 1 3, 3 plus 2 5, plus 1 6, 6 plus 3 9, 9 plus 2 11. And AD, since he is covering AD twice, so with 11 you can add 2. So 11 plus 2, 13. So this will be the distance he had to cover. You can see same route is given, and all the route that traverses every edge at least once, will have weight equal to the sum of the weight of all the edges plus the weight of edge AD. So total weight will be 11 plus 2, that is 13, which will be the answer. If there is doubt, you can ask me in the comment box. Let's do one more. So next, solve the Chinese postman problem for the weighted graph test. Now here, if we check the degree, for A it's 3, for D it's 3, for C it's 3, for B it's 3, for E it's 4. 1, 2, 3, 4. That means out of 5 there are 4 vertex which had degree odd. Okay, so that means more than one edge you have to cover twice. Okay, so we'll select the shortest one. So since 4 vertex is there, so we can make a pair, that is AB, and CD can be one pair, that is distance of AD CD here to cover twice, or it can be AD and BC, and next it can be you can take the diagonal also, AC, that is diagonal vertex. Okay, AC and BD. Now ABCD. So from A to B, which is the minimum? See, A to B can be covered directly from here to here or through E. So which one is minimum? 4 plus 5 is 9. So 8 is minimum. Okay. So we have to take 8. And from C to D, which one is minimum? If you go directly, it will be 6. If you go from E, then it will be 3 plus 2, that is 5. So 5 is minimum. So if you add 8 and 5, that is this one and this one, so you will get 13. Next, ADBC. So AD minimum is 4, 6. So if you want to go from A to D, you can go through E, which will be minimum. So 6, and from B to C again you can go through E, it will be 8. So 8 plus 6 is 14. Clear? Now the last pair, that is AC and BD. So from A to C it will be 4 plus 3, 7, and from B to D 5 plus 2, 7. So 7 plus 7, 14. So 14. So you can take this pair since this one is minimum. So to cover all the distance, if it starts from any vertex, suppose A, and it will end at A, and if you want to cover the minimum distance, you have to cover AB and CD twice. So to find the minimum distance, you can add all the weight, that is 8 plus 9, 6, 7, 2 plus 4 plus 5 plus 3, and with this you can add 13. Let me show you the solution. You can see they have used this pair AB, CD, and from A to B, this is the minimum, A to B, and from C to D through E, because this is minimum, which is 5, so 13. So you can take this pair, and what is the total weight? See, if you count all the weight, it's not shown here. So if you count all this, that is 8 plus 5 plus 9, you will get 44, and 44 plus 13 will be 57. So you will get 57, and this is the path. Clear? So if there is any doubt, you can ask me in the comment box. So that's all in this video. So we have discussed postman problem, the Chinese postman problem, and Eulerian graph. So in next video, we will continue this chapter, and most probably we will complete this chapter. So thanks for watching. Let's meet in another video.